Okay, so the next presentation will be about construction in the offshore area. This also includes the leg monitoring system, although it's not the main part, but it's one part of the system. And it's mostly used for rig moving and barge, maybe also a little bit of barge and tug management is also included, but the most part is moving of rigs. In this particular picture we have here a jack-up vessel which is used for offshore wind operations. But that's different to the oil and gas industry, where you normally have rigs which are not self-propelled. Then you need some tugs to tow them to the final position. And we have also a single software module which is able to monitor the legs of such a jack-up rig. This was originally developed to give always an overview how deep the jack-up legs are inside or lowered into the seafloor. And then in addition, with a motion sensor on top of the deck, you can monitor if the whole deck is moving or slightly decaying. So for this application for the construction and the positioning, we mostly use one module of the whole NaviSuite, and that's the NaviPack software. So this single module can be used not only on one vessel. So if you have, for example, a jack-up rig which is towed with some tugs around, then you can use just one NaviPack license for the main barge and some tug licenses for the small tugboats. And in addition, you could also use NaviEdit. NaviEdit is a simple tool for quality measurement and editing the positioning data. The advantage is if you have already a NaviPack license for other tasks in-house, then you could easily switch over to this application and use the same software basis. So the jack-up functionalities of the software include a 2D helmsman display. So on board of a vessel we typically have a survey PC where all the sensors are plugged to, and then we can locate different helmsman displays somewhere on the vessel for the navigator, for example, that he gets the overview. We have a survey PC on board where all the sensors are plugged in. And then we have some, maybe several helmsman displays. That simple display can be used either only as a monitor to monitor the movements of the vessel, which are just forwarded from the survey PC. For example, you can use that in the operator's room where they are operating with a crane, or maybe we have other operators on board, for example also the helmsman himself, who is doing some navigation services on board. Then we have a NaviPack online 3D module that shows the whole scenery in 3D. I have some movies which I show later on, and they can display what I mean. And as I already said, there's a special software tool which allows the monitoring of the legs. And we have some tools for that's included in NaviPack, where you can use the construction guidance. That could be easily, for example, if you have the shape of your rig, then you produce a template of this rig and place the template in the final location. And then you sail by the assistance of tugs to the final position and bring your vessel with this template to coincidence. Yeah, and as I mentioned already, for this purpose you also would need, if you have tugs, then you would need something like a tug management system. Tug management needs, it's only that you have positioning devices on all the tugs, also on the final barge. And then you have an overview where all the tugs are moving from the barge, and on the other side you have an overview from the tugs where the barge is moving. Additionally, we have developed a special module for catenary calculations. That doesn't mean nothing else than that you control, for example, if you have a barge which is held by anchors, that you can pre-calculate the chain, the anchor chain, which is maybe consisting of different type of chains, ropes and things, and then you can calculate just the normal line of the chain and of the ropes. Okay, so here's an example of a 2D helmsman display with a rig in the background. And as I already explained, this, for example, here is a typical template or a ghost, how you call it, in the construction industry. And this is the rig and the helmsman of the tugs. They are trying now to coincidence this form with a template. In addition, you are also allowed to use maybe a pre-survey of the area, and you can load these data into the background. Or even S57 charts can be used as background information if you need special navigation lines. And the software allows also that you install one license, for example, in your office, and you make already a pre-planning of the whole survey tour. Here you have a typical application. You see here the main barge held by 3 tugs, and then you have there the ghost position and close to the rig where you want to place this. Here you have the leg position, 2 legs of the rig. Then you have the navigation instrumentations below, and you have some other the vessel position there. Then you have always a cursor position, so you can define this like you want, so you can place the different small windows in the case or in the position where you want to have them. And here you have also something like a multi-beam survey in the background, which shows the actual depth, and here is the scale of the depth. And the advantage of our tug management system is that you have this picture on each of the 3 vessels. You have it on the platform, on the rig itself. You have it also on the 3 tugs. So for this approach, you can define a survey line, or that's just the course as it should be, the course of the main rig. And then you may have seen that during the navigation, the rig follows always this line. Next. Then we have different other things to add here, safety zones and collision warnings, so you can define some circles around the structure, so that if the rig is approaching this area, then it gives an alarm for the tugs that they have to lower the speed. And then you can see here also a little bit clearer that you get the navigation of the tugs also displayed on the rig. So first we have seen the scenery in 2D, and this is also possible in 3D. This is depending, so we use normally, you have to use some 3D models of your vessel, of your rig. This can be forwarded as 3DS modules, and 3DS files can be developed in AutoCAD. What you can see here also in this picture shows the hydroelectric data, so the multi-beam data, with the different holes where the rig has already been placed. And as I already explained, the software already keeps an overview of the rig position, the tuck position, and the target position in this picture of the platform. And the ghost position, as mentioned here, can be also shown in the online 3D module. So this is the original rig, and this is the template position where the rig should be moved to. As additional features, we can include 3D profile views of the legs and the platform during jacking of the legs. A 3D profile of the cantilever, which can be moved out here. The current direction as a vector. And yeah, planning of ghost positions, that's something which you do already in the office. Yeah, now we come a little bit more into details. Here you see the jacking operation, and you see how the jacking legs are monitored. Until they are settled now. And then this allows that this leg position is constantly monitored. And if you already also have a motion sensor here on the platform, then you can also monitor if you have some movements of the platform itself. And from the jack-up legs, from each leg sensor, you can see how the behavior is of this leg or the next leg. The original purpose of this module was that in case of any accidents, so for example, if you have a lot of holes already on the seafloor, you must be always aware that you should place either in the same positions your legs, or you should use a new position. Otherwise, there's always the danger that if you place your leg close to one of these holes, that the jack is, or that this leg is just breaking into this hole, and the whole platform is not stable any longer. Yeah, now we come to the cantilever. Here you can see the operation of the cantilever. So it can be also operated, and you have a direct look on the cantilever how it's handled and which position it is. That can be very useful, especially when you want to place your rig in a specific or in a required position. Yeah, now we showing here that the operator is free to move around and to have a look from each side of these of your rig, and to get a good overview what is happening in the moment. This can be useful, especially when it's when the rig is very close to the platform, and you want to monitor what is going on, and are there any obstacles, or when I want to move down my drilling rig. So now we showing the full operation in 3D again. And as I already said, this is not only possible online, you can also store the data and replay them afterwards. That may be useful if you, especially for quality tasks. To handle this kind of display on a PC, you need a powerful graphic card, and but the PC power, I think, is a normal PC which you can sell or which you can buy, not around the corner, but from a specific purchaser. Okay. So now we come to the alphanumerical display that looks a little bit, not very clean in the first moment. But that shows in details, also in numbers, all the different legs, the height of the legs, and the pressure on the legs. And this can be very useful also in case of accidents to detect early when something went wrong or goes wrong. So here you have the depth over time as a quality view, and here you have the pressure over time. Please move to the next. Yeah. So this is another guidance example. This is a typical windmill rig here. And the guidance, we normally use a lot of sensors on these kind of rigs because you need redundancy in case that anything happens during the operation. Yeah. And when the whole platform is jacked up, then you can here have an overview of the motions data, so the roll, the pitch, and the heading data. And on top, you see that this platform is equipped with 3 GPS antennas. But these kind of operations can only work if you have a very accurate GPS. That means normally you need an RTK solution, that means around 20 to 30 centimeters of accuracy. This can be either achieved with a RTK reference station, or you use satellite corrections, for example. But this solution is only working up to a certain limit. That means 10 to 15 kilometers from the shoreline. If you're working more outside, so more far from the shoreline, then you need something like satellite corrections. And there are several suppliers on the market, like Fugro, for example. They have the Marine Star operation. Then we have CNAV. They have a known net of reference stations over the world, covering the whole coastlines. And then these reference stations and the positions are calculated for your, are sent to a satellite, and then you can apply to the satellite. You have to pay a monthly or a daily fee, and then you get these corrections directly on your vessel. Then we come to a little bit more to the TAC management system. As I already explained, the TAC management is consisting of a central barge or a platform or a rig. I mean a rig or a barge. Then we need some TACs, which are towing the main barge. And we have an anchor handling situation in this case. So the platform or the rig is handled by anchors or fixed in a position. And then we have some small anchor handling boats, which are handling the anchors between the barge and the final anchor position. And in the final position, then the anchor handling boat clicks when he has released the anchor, and then this position is fixed and sent over to the barge. So the barge knows already where this anchor is placed. And the data transfer between the barge and the TACs is mainly done by radios. So normally you use UHF radios for this purpose. You can also use wireless LAN, but this is limited to a certain distance. But we use wireless LAN, for example, on these jack-up rigs. For example, to if you have mounted a GPS antenna somewhere on the legs and send the data via wireless LAN antenna directly to the survey PC. Yeah, this is a typical 3D display of a barge here, the barge, and with a lot of anchors. And these 3D displays shows also how the anchor handling is done. Here you see the anchor handling boat, and one chain is going to this anchor handling boat, so the anchor is placed on this boat. This is a typical catenary line of an anchor chain. So you have some midline buoys here. They are placed on the surface, and this is a rope, and then finally you have the chain to the anchor, which is placed somewhere here. And the software is calculating these curves, so that's the catenary curve, based on the parameters of the physical parameters of the chain and the ropes. Yeah, this is a typical report of the different anchors, which you have then as a quality report for the final report. End of operation reporting we have. Then we have final positioning reporting. So if the rig is on the final position, and event-based reporting, that's if the operator presses the event, then it's always storing a position in this point. And here you have the overview of the anchor positions. And in addition also, here you can only see the winch, but that's also the 10 winches which you need to handle these 10 anchors. So this shows finally this full system setup. First of all, you have the NaviPack, then the tug management system if you need. Then you need some configuration and drawings of the platform and the rigs and tugs. Then you have the possibility to position the rig, the jack-up legs with a special leg monitoring, the cantilever push, which is also a special tool that always needs sensors. So if you have connected sensors, for example, to the jack-up legs, then you can also monitor the jack-up legs. And then we have the possibility to store this whole setup, which you have here, in one file. And if you need this for next operation, for example, you establish the rig, and then afterwards you want to demobilize the whole thing, then you can just reload this configuration onto your PC. Here's a list of the sensors you would need for such a setup. It's first of all the computer with the NaviPack and several helmsman displays. Excuse me. The advantage of NaviPack is that normally you have only to buy the NaviPack license for this operation, and the helmsman displays are free of charge. So that's only, some computers, or even if you just want to double your monitor, that means you use monitors or a splitting cable for your monitor. Now we come to the positioning sensors. That's normally GPS with backup, motion sensor, and gyro with a backup. If you have more than 2 GPS, so it means 3 GPS antenna, then you can also calculate the motion of the platform directly from the GPS positions. A total station could be used. Total station is a typical survey instrument for tracking the pre-position to the final position. That means, for example, for the cantilever arm or for a pile gripper or something. Or otherwise, you have here sensors for the leg movement, for the cantilever push, and maybe also an ADCP which can be used to monitor the current. Next, please. This shows also an offshore setup, but this time with a vessel. So you need real-time monitoring of crane and foundation positions, for example, for offshore wind. Then the Legmon system enables you to automatic monitoring your jack-up legs and enables an early detection of any incidents. So already in this stage you can see that NaviPack is a multi-purpose software, and I will show you later in the later afternoon when I give an overview of a NaviSuite that NaviPack can be used for a lot of different operations. So that's all from the construction side. Are there any questions?
What information do you need to upload in the system? What information do you need to load into the system?
What information? Normally we use serial data, but it is very much depending which kind of sensors you want to connect to the software.
For example, we were talking about the pressures that you can have there. It provides you with information from pressures, but he said that when they are using the systems, they have to upload information about the possible penetration of the legs into the seabed and the preload information. But is that done automatically? How do you get that information?
That's all done by sensors. So you need some sensors which are indicating, for example, the leg extension. And on the other hand, also if you want to include pressure, then you need something like a pressure sensor which interfaces the data into the system. Yeah. Yeah.
Is it wired from the sensors?
Yeah. Normally, yes. But you also can use wireless, because on big rigs, I know that you don't want to stretch 100 meters of wires over the whole platform, so you can also use, we often use wireless LAN for this. So with direct antennas, which are pinpointing to each other, so that you can load the data directly from this. If you have, for example, on a very far position mounted some antennas of GPS or maybe another sensor in a remote location where you don't have any access and you don't want to stretch any cables over the deck. So to avoid these, you can also use wireless LAN. Yeah.
Because of the delay on
that. Yeah, we know. But this is, you normally use one PPS signal from the GPS to synchronize all the sensors. Or we even have another possibility, that's a box, which we distribute, a box where you can input all the sensors. They are time-tagged in this box. That's a Linux-based PC. And then only one Ethernet cable is running to the survey PC and gives you already each interval time-tagged directly to the survey PC.
Is this a subject you can get into details when we come to the...
Yeah.
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 Mm-hmm.
No, it's a reduced package for each TAC. No, it's just normally on a TAC you have we normally use hemisphere, for example, combined GPS and heading sensors. They are just placed there. Then you get the connection into the data, and the data is distributed to the barge. And then you have a very reduced package that costs only about 1,500 euros or something, and then this package is for each TAC you need. Yeah, for example, yeah. But we have different kinds of telemetry also with these TACs, because we have three different modes: synchronized modes and asynchronous modes, and yeah. That's normally depending. So if the operator is already experienced, he can do everything by himself. But if he asks us, we can also offer that we do the installation of a full system. That's no problem. As I said earlier this morning during the initial demonstration, we are not only offering the software, we can also offer the hardware. So we can offer full systems with installation or integration, setting to work, and training afterwards. Okay, thank you for your attention.